All right, so I think I'm recording. Let's take a look at solving these two quadratic inequalities. Um, we know that the graph of a quadratic function is a parabola, and that's how we're going to approach these, is to look at the x-intercepts of a parabola and then kind of go from there. So let's take a look at number one. Um, I'm going to ignore the inequality and just set this equal to 0 and solve as my first step. I like to have a positive leading coefficient, so I'm going to change the sign of all the terms. And since the leading coefficient is different than 1, I believe I can factor this, but I'm going to use the x method to factor it. Negative 6x and 5x, I believe, do the trick that negative 6 times a positive 5 is negative 30, but yet when you add these together, you get negative 1. So let's put this information in a table. Along one diagonal, we put the first term and last term from the original equation, from the equation that I've written in standard form, I should say. And then in our x method, um, we write the values that we found in the x method along the other diagonal. And now we look vertically and horizontally and factor. So let's take a look. 2x times 1x is 2x squared. 5 times 1x is 5x. 2x times negative 3 is negative 6x. Positive 5 times a negative 3 is negative 15. So everything is looking good so far. We can rewrite this equation as 2x plus 5 times x minus 3. And that will give us equation solutions of negative 5 divided by 2 and of positive 3. So let's put those, let's look at a number line and find those values on a number line. So this negative 5 halves is a number that's to the left of positive 3. And that's as detailed as I need. Now I need to decide whether I want these critical points, if you want to call them that, and they often are called that, whether they're in my solution, included or excluded from my solution set. And that I look to the original inequality here, and since it's underlined, that means it could equal 0. And if it was not underlined, I would leave these hollow and exclude them from my solution set. But since it's underlined, since it could equal 0, I shade these in. So now I have to make a decision of whether I'm going to include the numbers that are between there or the numbers that are to the extreme, away from the center, in each tail area. And there I look to the parabola, y equals negative 2x squared plus x plus 15. The negative 2x means my parabola is opening downward. So I'm going to sketch a parabola passing through these 2 points, and those are serving as my x-intercepts. Okay, and now I want to pick the x's that will cause the parabola to be greater than or equal to 0. Greater than 0 is above the x-axis, so it's these points right here that are points on the parabola that are above the x-axis. Those points have x values that are between negative 5 halves and positive 3. So that's my solution set. pick any x that's greater than or equal to negative 5 halves, and yet at the same time less than or equal to 3. And I guarantee you, when you plug it in, you'll have a number that's positive or 0. If you pick a number that's outside of the shaded region, it'll be less than 0. It'll be a negative number. All right, so let's come on, and that's our answer. This is our solution set. So let's take a look at this next one, see if we can't do it in the same way. I'm going to ignore the inequality and look at x squared plus 3x minus 10 and set it equal to 0. And this one's a little bit easier to factor because the leading coefficient is 1. See, the last time the leading coefficient was something other than 1, and that's why the x method was so nice. With 1, it's pretty easy to see that x times x is x squared, and then two numbers that multiply together to give me a negative 10, but add together to give me a positive 3. It's easy to see that I want plus 5 and minus 2. So that gives me solutions of negative 5 and positive 2. And if I put that as x-intercepts on a number line here, here's negative 5. Here to the right of that is positive 2. My first decision is to include or exclude those from my solution set, and I look to the original inequality, and since it says strictly less than 0, I leave both of these hollow. I'm not going to shade them in like I did last time, because last time we had the arrow was underlined. We had equality. This time we don't. So and this time the parabola, since the leading coefficient's positive, my parabola is opening upward. But this time I'm wanting values. I'm wanting I'm interested in the portion of the parabola that's below the x-axis. It says less than 0, so I'm interested in the x coordinates of all of these points that are below the x-axis, and so that's strictly between there. All right, so my solution set is from negative 5 to positive 2, excluding those endpoints. So I hope that helps, and I will talk to you later. Bye.